Thomas. Welcome. We're glad to have you with us to talk about automated discovery and management. So please take it away.
Okay, thanks everybody. Once more, welcome. This session is about automated, what we say, inventory discovery and management for both NMOS ISO4 compatible and proprietary, or let's call it probably legacy broadcast infrastructure. My name is Thomas Gunkel. I'm working for a company called Skyline Communications. I want to keep it very brief here. We are a software house. We are doing open monitoring orchestration solutions. We have a global footprint out there, about 350 people working for the company. What are we doing? We have one product only. It's called Data Miner. It's actually an off-the-shelf platform, a vendor-independent one, and we manage IT, media, broadband, broadcast infrastructure, can be on-prem, can be in the cloud. And we are very active in what we call service monitoring and lifecycle orchestration. And the third pillar is about managing processes, business, operational, technical processes. And one of those, and this is what we want to talk about today, is inventory management. Just very briefly to start with a few industry trends. When we talk about inventory management, what is required? It's actually everybody is after a single source of truth. You want to have a single overview of your inventory, documentation, wiring, addresses, also people probably. Everything needs to be consistent. An interface between a system, a management system that looks into the network, the is network, and your CMDB database must be in sync. You don't want to do this in a manual way. There's a lot of dynamics nowadays in systems. Moving away from more legacy SDI infrastructures, which were pretty static. We have a lot of virtual infrastructure. We have a lot of software infrastructure that needs to be managed as well. That comes on and goes off, maybe on a daily basis. Big topic is certainly security. Don't forget about that. It's all about onboarding new infrastructure, or infrastructure that was off and comes back in a very secure way. Manage the right software, manage configurations, etc. And how do we do that? It's all about, at the end, automation. For all those aspects we talk about. So a few things on inventory management. How does it start with? It starts with discovery. First, you need to find out somehow what's in your network, what needs to be managed. There's a few things you can do. You can scan the network, or you can connect to a database. Then you have to provision the equipment, your devices. That's actually how to add those devices, those elements to your management system, to your inventory management system. You don't want to do this in a manual way. Then you need to configure your inventory. Before you actually use it, make sure it has the right configuration, the right software image is loaded. Same for the software updates. Make sure the firmware is the right one. You have the right base software. That all goes together. There's another topic we will briefly touch. It's about rec managers. Mainly to replace maybe your AutoCAD drawings, which are also static, showing your recs. You want to have that automated as well. So many aspects, but everything starts with discovery. And what is that about? When it comes to discovery, this is where NMOS comes into play with ISO4. And that's one way how to discover new inventory in your network. So basically, we have two things here. We have the NMOS infrastructure, and we have the proprietary or non-NMOS infrastructure. The way we do it, our proposal here is, we have the NMOS registry. That can be just from anybody, third-party registries. The management platform connects via ISO4 with the query API to the NMOS registry, gets notified about new infrastructure, and needs to manage the infrastructure. If it's non-NMOS, what can you do? You typically can scan the network. You just fire commands to the network, see if you get some reaction, and I will show how that could work. And once you get a proper answer, you know that there is a device that was added to your network. And the third one, not to forget about that, is really more when it comes to IT, the CMDB databases. Those databases almost every company maintains. To just maintain on a database, not to look into the real world, what do you have? That's all your equipment. Those are also persons. This is cables, just everything you have in your inventory database. This can also be a trigger when you add somebody or something to the database that the management platform gets informed. An important thing here is a so-called CI type or configuration item type. What is that? I checked the internet. It's defined commonly as a CI type, identifies attributes and relationships that comprise a configuration record. So everything you need to know what you need to do with your equipment. That can be hardware, software, documents, also users. Today we focus more on hardware and software, obviously. So let's have a look at one workflow for non-NMOS devices. How can we discover? We need to scan a network range. You don't have to scan the whole network. Typically, you know when you add new devices in which network range that should be through your DHCP server. The management platform needs to provision the inventory. And then once it's under control of the management platform, once we have access to that inventory, we can interface via so-called, we call it connectors, to the actual inventory. And those connectors are often built on a single vendor API, or nowadays much more often on multiple vendor APIs to get full access to each and every metric, each and every parameter of those devices. So a few steps from discovery to provision until you are able to monitor, control, we say manage, orchestrate all the devices. Very important here, there is this transition period when the equipment is not ready yet. It's somewhere in the provisioning, onboarding process until you have it in a state where you can reuse it, where it's ready for production, as we said. How do we do that? How can we discover infrastructure? And what we did, we defined so-called discovery profiles. So you ask the network by sending certain commands. That can be HTTP commands, HTTPS, classic SNMP, WMI, Telnet, all kind of different protocols. You fire some of those commands to the network, and then you identify, if you get a proper answer from one IP address, that there is a certain device type out there. And I just took a few screenshots. Let me make this a bit bigger that you can also see that, what we do there. On a Windows operating system, that's also something you want to identify every now and then. We talk via WMI commands. If there's a certain value on the system name called Microsoft, we know we have found a Microsoft OS. Or on an Arista switch, just two examples here. If the sys object ID has a certain value via SNMP, we know exactly which switch we have found. Same for another one, really on the model number, or on a Cisco switch here. Pretty simple approach to discover infrastructure which is not supported by NMOS ISO 4. What is the next step? Once you have found it, you need to do something with it. You need to provision your infrastructure in that management platform. There we define again profiles, and we call them provisioning profiles. You need to set a certain set of rules in there. Simple things like, which name do you want to give your device? Some naming conventions, where to put it in your system, in like a view structure, what you see here in the middle. Most important probably, which is the connector and the connector version you want to start communicating with that device, because so far you only found it. You can't do much with it yet, and you have to attach the right driver connector to that device. Let's assume you have found an Arista switch, as you can see here. There might be switches in your network with a certain firmware, which is a bit older, and some switches with the latest firmware that requires a different connector type because it supports different API commands. Based on the maybe firmware you see, you find you have to do certain rules to say, I want to control it with connector A, and another more up-to-date version with connector A, and the later version, depending on the firmware version. Also, alarms and trend templates belong to that one. What is this about? Those are templates of all the metrics you want to monitor the switch, in that case, against, or the devices against. The trend templates is about performance monitoring to monitor performance over time. Don't forget about passwords. That's also important because many of those APIs to start interfacing with, you need to enter a user and password, your credentials to that switch, to that device. More here, the element state. Once I have provisioned it, do I want to use it already, or is it maybe still in standby state because I don't want to use it yet in production? And then also here we define additional links, very often to CMDB databases. from the customer, for example, where we find additional information, and where is that device, in which rack, to create racks automatically, and what is the power consumption, to do some calculations, etc. And once that is done, once we have defined such profile, we can automate the process. So far we have automated the discovery and provisioning. And on the right-hand side, you see one of those examples. That's an example from an Arista switch, where you see a lot of different APIs a connector is made of, like SNMP connections, a certain dedicated API from Arista. We need to specify how to receive syslog messages, how to do something on OpenConfig. So it's a mix of many APIs that make one connector that allows those systems to interface with some of those devices. This is just an example how we call it a managed element looks like. You have access to just everything those devices do. That's again a switch in that example, where we can monitor, where we can control the switch, where we have access to each and every interface, to SFP data, the optical values. Then there's another screenshot here where we get some flow data. It really depends on the capabilities of each and every device we interface with. That's one part. Now, the more important one, the NMOS workflow. How do we do that? Instead of scanning the network, what can we do? We can interface with the NMOS registry, as we said. The management platform subscribes there. We need what we call a connector that talks ISO4, that query API. And once we have discovered the device, and that's important, the workflow is just the same. We start a provisioning process for that NMOS node. And once we have provisioned the node, the device, we can start interfacing via connectors. That can be, again, an NMOS connector, something ISO 5, ISO 8, or can be the proprietary ones provided by the vendors. But overall, the workflow at the end, once we have provisioned things, a certain node, a certain device, is the same for NMOS and non-NMOS devices. A few more details. That's a screenshot from our lab, where we were using the Mellanox NMOS registry, but that can be any registry out there. We have that ISO4 query API. We have a so-called ISO4 connector that allows us to talk to the registry. So what happens? A node registers to the registry. That connector in the management system detects the new node in the registry. And that's important now, identifies if the element was there before, exists in the management platform, or if it's really a new one. So those are two basic use cases to us. Just two more screenshots here. And that's how we interface with that registry connector through certain API versions of the NMOS registry, in that case 1.2 or 1.3, small details. On the left-hand side, you see everything you can get from a registry, the nodes, devices, sources, flows, senders, receivers. That's a screenshot from the senders, where we have access to the SDP files. So the system needs to have access to everything that's already in the NMOS registry. That's basically it. And then we can run those, what we call processes. That ISO4 connector triggers that process with a token to either provision, as we said, a new node. That's like we define those processes in BPMN language, or update an existing node. So when there is a new node, the first time that node ever shows up, what are we doing? We identify there is a node, we talk to the IP address of that node, and try to establish a real connection to make sure that device is doing well. And then we provision the node or that device. For an existing node, for example, you have a camera on your OB truck, you turn it off, you turn it on, 2 days later, the camera was there before. You don't have to start the whole provisioning process, but it might show up with a new IP address. So we have to also do that little change, reapply what we call that CI type on that device to make sure we still have access to historical data and don't lose all that data, everything we have done before with that device. How does it look like at the end? Similar to for what we have seen for the non-NMOS devices, you get a list of devices. In this case, again, just examples, encapsulators to decapsulators from Imagine and from Riedel. A few details for those who are familiar with all the details on ISO4. how do we sync and keep track of what we call a managed element, that one here, and the actual NMOS registry. We are using the node GUID. That's really in line with the ISO 4 specs, saying whenever there is a physical node, that node ID must be unique, can never change. So when you have a physical camera, it's like a MAC address, that node GUID will never change. When it's off and on, that management system will identify it again. For virtual nodes that could have a new node GUID, in that case, we would also create a new device that did not exist before. Once more, a few examples, just screenshots. That's a Riedel SFP. You see a lot of data on the left. Let me make this a bit bigger, like info on license, firmware, LLDP, packet interval timing, the flows, the most important one. More information also on the firmware, for example, which is the application running on it. At the end, again, everything the vendor provides for that specific device can also be ISO 5 commands. Another example from Imagine, a little bit of a different API, but similar information on the IP multicast streams, but also information on something which is outside of NMOS through the API, like control on the color corrector, or what is in here, some PTP metrics to monitor and also to set your PTP ecosystem. What did we do so far? Are we done yet? Probably not, because we discovered either through a network or through NMOS, the device. Then it comes all together in that provisioning process. So we did not stop yet here. We are not ready yet. We just provisioned the equipment. NMOS, non-NMOS, but there is more to do. And that's not always a must, but better think about it. You need to make sure that you have the right configuration, the right firmware. Also, you're interested to discover connectivity. That's not done yet. And maybe the rack management to build those rack views automatically. And very briefly here, just a few ideas what you can do. Again, we do it via CI types under the hood, because you have to do configuration management, firmware management, connectivity discovery, really dedicated to the infrastructure. They all support different APIs, different capabilities. What we actually do under the hood is writing automation scripts to support the Imagine SMP, the Riedel SFP, the Arista, the Cisco switch, my examples I used so far. A few more things here. How do we discover connectivity? Very often through LLDP tables. That's common. Works with all the big network switch providers, like again, Arista, Cisco, Juniper, Huawei, to read LLDP tables, to learn about the neighbors. That's a protocol where you can read which is my neighbor from a switch. And then you can do things like those typical network topologies, what you can see here. A few switches. Here are my encapsulators, my decapsulators from Imagine. Down there, you see those from Riedel. That's information you don't want to add manually. You also want to automatically extract from the network. Second, firmware, software management. You want to be able to define the firmware you use for your inventory, and then we can compare. That system must be able to compare that against the real one. And if you connect a new device and it has an outdated firmware revision, either you get a notification or you just automatically update to the very latest firmware or software image. Configuration management, it's to apply maybe a golden initial configuration, being able to take backups and compare configurations visually or also fully automated. A lot of things, again, you have to do. A good example here is always, on a very simple example on a switch, remove the default admin account and password. It's just one command, but you should automate that. Rack management, to automatically build those racks. When you have the information from a third-party CMDB database, there's no more need to create an AutoCAD drawing. You can automate that process as well. And when to run all those processes, use a scheduler, because not every process runs 24/7. Like this ISO 4 process we talked about, this can run 24/7. You just always connect to the NMOS registry. When something changes, you want to get notified. But software, firmware upgrades, you might only want to do once a month under a very controlled way. I mean, maybe only for a certain network infrastructure, not for everything you have. So it's all about doing the right things at the right time and to do it in an automated way. And only then, and that's maybe the core message here, once you have successfully onboarded your equipment, and that's not done with discovery only, when your equipment is ready to use, and here's a simple example to follow the NMOS ecosystem when you want to do ISO 5, don't just probably use that new source and destination, your encapsulator, decapsulator, and add it to the SDN controller. You can do that once it's ready, but more often you need an additional approval workflow. So there's another process coming. It's all about automation, maybe sometimes in between with some extra approval workflows that somebody says, yeah, that's a new camera, I want to add it as a new source to my SDN controller. And only then start using the connectivity via ISO 5, ISO 8, or again via proprietary API. As a summary, what we have seen, we can use ISO 4 compatible infrastructure and proprietary one in a single system altogether. That's good. ISO 4 is great to do that, but it's one part of the puzzle probably of a full inventory management system. And automated infrastructure discovery, as we said, is not enough. It's not sufficient to use your equipment in production. There are a lot of things you need to do still, and you should automate that before you can use it with your SDN controller, as an example. And to do that, you should not do it manually, do it in a more automated way. And why is that? It's really to bring security, to be fast, etc., but to add more security, to have something which is predictable, that you can only do when you automate those things. And my very last one, and I'm running out of time here, is just a few screenshots from Google. When you have a look what happened recently, or what happened 5 years back, this was TV5 in France, which was highly impacted by security breaches. And just recently what happened with Channel 9 in Australia. It's about security, not to risk that you get hacked, that you get into big trouble. And maybe just because you overlooked one system running on an old software that was an open gate for some of those hackers. And with that, I'm done. If you have any questions, feel free to ask now or get in touch with me later. Thank you.
Thomas, thank you very much. Very good presentation, and I think you make a very good point that simply discovery and registration are not enough really to fully implement these automated facilities. You really have to go through many more steps. Thank you so much. Great to see you. I hope we see you in person sometime soon. Take care.
Yeah, thank you.
All right.